The amount of solar energy that reaches the Earth's surface in a single hour is vastly greater than our annual energy consumption. Indeed, the US Department of Energy estimates that the total amount of energy we use in a year is around 410 quintillion joules. That means 410 with 18 zeros after. In 1 hour, the sun hits the Earth with around 430 quintillion joules. The untapped potential that lies in solar energy is huge. Furthermore, it's one of the most sustainable power that helps reduce dependence on fossil fuels. Solar technologies come in various forms, but there are two methods we will explore: photovoltaic systems and thermal systems that use heat from the sun. Photovoltaic systems convert light into electricity thanks to solar cells. Inside, there are materials like silicon that absorb light energy. There are two layers, an N-type layer, N like negative, with an excess of electrons, and a P-type layer, positive, with a deficit of electrons. In between, there is a junction that acts as an electrical barrier. It's a layer of pure semiconductor crystal, which is called the depletion region or PN junction. Long story short, sun ray is light and light is made of photons. When it strikes the surface of the solar cell, it interacts with the materials. This interaction causes the photons to energize the electrons in the materials, freeing them from their normal positions and creating an electrical flow. The PN junction acts as an electric field and helps direct the flow of electrons in a specific direction. A single photovoltaic cell produces a small amount of electricity, and to generate a useful amount of electricity, multiple cells are connected to create a solar panel. When the electrons move like this, they create a direct current of electricity, DC. However, most of our everyday devices use AC, which stands for alternative current. To make electricity usable, an inverter is used to convert DC into AC. Solar thermal systems, also known as concentrated solar power or CSP, operate by using sunlight to generate heat, which then can be used to produce power. Mirrors or lenses are used to concentrate sunlight onto a small area, usually targeting a receiver or absorber, increasing the intensity of sunlight at that point and converting it into heat. Those collectors can have multiple shapes: parabolic, tube, towers. It all depends on the design of the system. The heat absorption often involves a working fluid like water, oil, or sometimes molten salt. Then the heat is used variously. For example, we can use heated water to create steam that can be used in a turbine and create electricity. There are more applications to discover with the solar thermal system, from solar desalination to space heating. Its versatility makes it a promising technology for a range of applications. But one of the most convenient advantages of solar thermal is its ability to provide dispatchable power, meaning they can continue generating power even when the sun is not shining by using stored heat. This characteristic makes them a valuable complement to intermittent renewable sources like solar photovoltaics. In this module, you will deep dive into the photovoltaic systems and the ones using heat. You will also see some design examples of solar plants and how to install and maintain them. In the end, you will learn economy can be applied to solar energy production.